5.2g, volume of cylinders. A cylinder is a solid object created by joining two identical circles together. So a cylinder might look like this, by joining two identical circles together. The volume of a cylinder is given by the following formula. Volume equals pi times the radius squared times the height. And let's think about this. So the area of a circle should be familiar here. That's the area of a circle, pi r squared. Well, why is the volume of a cylinder so similar to the area of a circle formula? There's just this extra height term. Well, if we want to find the space this fills, we have to find how much this is, and then multiplying it by the height here is basically dragging it through here and making it a solid shape. So that's where this formula comes from. So with that being said, let's go ahead and use it to find the volume of some cylinders below. So find the volume of this cylinder. We're going to use the formula, V equals pi r squared h. So pi is pi, r is given as 3 inches, and we square this, and height is given as 7 inches. So we can, after we multiply this out, 3 squared is 9 times 7 is 63 pi inches cubed. Volume is always measured in inches cubed. And we don't have to expand the pi. Example 2. Find the volume of the double-decker tank shown below. So to calculate the total volume, we need to add the smaller tank and the larger tank together. We need to add the volumes. So let's find the volume of the smaller. Volume is equal to pi r squared times the height. We're given that the radius is 2 meters to plug in for r, and the height is 4 meters. This gives us a pi times 4 meters squared times 4 meters. This is 16 pi meters cubed. Now calculating the larger tank, volume is again pi r squared times h, and we substitute in 4 meters for the radius and 3 meters for the height. This gives us pi times 16 times 3, which is just 48 pi meters cubed. Now what we need to do is add these two together. So the total volume is just 16 pi meters cubed plus 48 pi meters cubed. This is 64 pi meters cubed is the total volume of the double-decker tank.